Hello, my name is Venisha Parmar. I am from ICT department at Marwadi University, Rajkot. This video is part of my subject Introduction to Communication Engineering. It is guided by our HOD Professor C.D. Parmar sir. Here I will explain you about time division multiplexing. So let us begin with introduction. In real life we have links with limited bandwidth. Bandwidth utilization is the wise use of available bandwidth to achieve specific goals. Efficiency can be achieved by multiplexing. So what is multiplexing? Multiplexing is a set of techniques that allows the simultaneous transmission of multiple signals across a single data link. In multiplex system, n line shares the bandwidth of one link. Multiplexing is the sharing of a medium or bandwidth. It is the process in which multiple signals coming from multiple sources are combined and transmitted over a single communication or physical line. This figure shows the basic format of multiplexed system. The lines on the left directs their transmission stream to a multiplexer, that is mux, which combines them into a single stream, that is many to one. At the receiving end, the stream is passed into a demultiplexer, that is demux, which separates the stream back into its component transmission, that is one to many, and directs them to their corresponding lines. In the figure, the word link refers to the physical part and the word channel refers to the portion of a link that carries a transmission between given pair of lines. One link can have many channels. Let's see types of multiplexing. There are three basic multiplexing techniques: FDM, WDM, TDM. So they are frequency division multiplexing, wavelength division multiplexing, and time division multiplexing. First two are the techniques designed for analog signal and the third designed for digital signal. So here we will see about TDM in detail. Time division multiplexing is a digital process that allows several connections to share high bandwidth of a link. Instead of sharing a portion of the bandwidth as in FDM, time is shared. Each connection occupies a portion of a time in the link. Here, all signal operates with the same frequency at different times. Now let's see the conceptual view of TDM. So this shows the TDM process. Here it is mux and this is demux. Here are some input devices and these are the output devices. You can see this is channel. It is single channel and time is allocated to each devices, that is means this 4, 3, 2, 1. This is the time slot which is allocated to each device. So what does it mean? Let's say source 1 wants to send its message. But at a time, source 1 cannot send its complete message. It can send the message in its allocated time slot only, this. Similarly, other source can send its message in its specific allocated time slot only. It cannot send its complete message together. So all the messages are sent in its individually allocated time slots. the here in demux, all the combined messages will be reassembled and then it will figure out the actual message. There are types of time division multiplexing. So we can divide TDM into two different schemes, that is synchronous TDM and statistical TDM. So let us discuss these two schemes in details. First we will discuss about synchronous TDM. Here the first point says input frame already has a slot in the output frames. It means the data flow of each input connection is divided into units, where each input occupies one input time slot, and a unit can be anything, one bit, one character, or it can be one block of data. Each input unit becomes one output unit and occupies one output time slot. A round of data units from each input connection is collected into a frame. It is not efficient because if input frame has no data to send, then slot will remain empty and in the output frame. Because of these, capacity of channel is wasted. Let us go through the figure of synchronous TDM process. So here multiplexer is there and you can see three sources are there. This one. The source 1 has 3 data, that is A1, A2, A3. Similarly, other sources has information with them. Here, the frame consists the data units from each input connection. And in frame, one slot is allocated for each unit. Let's say any of the unit is empty, then its slot will also remain empty in the frame. Now we will move to statistical TDM process. Statistical TDM is a type of time division multiplexing where the output frame collects data from the input frame till it is full, and it does not leave any empty slot like in the synchronous TDM happens. Here we need to include the address of each particular data in the slot that is being sent to the output frame. And compared to synchronous TDM, it is more efficient as the channel capacity is fully utilized and improves the bandwidth efficiency. Let's see the statistical TDM process through its figure. Okay, first we will see what was the problem with synchronous TDM. So, you can see we are having this line A, line B, line C, line D, line E. In first slot, we can see line C and line E is not transmitting any data. In another slot, we can see line A and line C are not transmitting any data. So, if we allocate the respective time slot in frame 1, we can see some empty slots. Why empty? Because as we are not sending any data, then 2 slots are already allocated. Because of these, channel capacity is wasted. So, to solve this problem, we require statistical TDM. This. Here we can see line C and line E is not transmitting any data. So here for A1, B1 and D1 only, for this 3 only the time slot will be allocated. For line C and line E, time slot will not be allocated as they are not sending any data. So, to have the idea about which data of channel is getting passed, we will put address there. Like this, frames are formed with the addresses and the data unit which is transmitted. For data A1, the address is A, B1, D, D1, D, and the line C and line E, which are not transmitting any data, their time slot will not be allocated. So this was all about time division multiplexing. These are the references from which I have taken this information. Thank you.